All right, so we calculated that the probability that it would take 7 rolls to get a 6 was 0.0558, using 5, 6 as the 1 minus p. N minus 1 would be 7 minus 1, and 1, 6 for p. And now we're looking at example 8.37 on 468. So what did you guys say? A? Yeah. Yes. Okay. What about B? No. And what else? It says record. Yeah. So we're just recording the number of times they make both shots. So let's say they make both shots. We keep counting here. And in a geometric distribution, you stop as soon as you have the first success. And so we're also, it's not defined, like, what do you mean by success and failure? Are you interested in the number of times they make both? They make one, that they make none of them? So this is not going to be a geometric setting. And the independence thing, right? Whether or not they make the second shot definitely depends on if they make the first, right? So what about C? Draw a card from the deck. Yes, and it's really important that it has the words in there, replace the card, right? If we don't replace the card, that's going to affect the probability the next time. All right, and then we get to D, the lottery. What do you guys think? Yeah, yeah. So we're just playing until we win. We're not changing the probability that we're going to win with each trial. And so they're independent. Where are we at? The last one? Yeah, E. So there's 10 red marbles, 5 marbles, blue ones. Reach in and without looking, select a marble. We want to know how many marbles that we'll have to draw without replacement on average in order to be sure that we have 3 red marbles. What do you think? No, yeah. So there's several reasons why. I think the clearest one is that your trials without replacement are not independent, right? So whether we get a red one or a blue one, that's going to affect the probability the next time. Okay, good. So let's skip down on that same page, and we'll just do one where we do a little bit more calculation before we move on. 839, right? You've got this hard data that suggests 3% of your hard disks are defective. You've been asked to determine what's the probability that the first defective hard drive is going to be the 5th unit that is tested, right? So let's clarify, right? This is saying you're going to test hard drives. What's the chances that the first one that's bad is going to be the 5th one that you've tested, okay? So X is the what? What's X representing here? Number. What are the trials? Let's be specific to the problem. And what are the units? Yeah, so the number of hard drives tested until what? Right. To find a defective. So if X equals 1, that's saying that we tested it and the first one was defective. If X equals 10, that means that 9 of them were good and the 10th one was defective. Right? So what constitutes a success? We're still in A. What constitutes a success is, right, a defective drive. All right, B. Let's answer the original question. What's the probability that the first defective one is the 5th unit tested? So from above, right, we're going to use that probability formula from right here. Right. So we basically, notice in the formula, we need N and P. We've got to have N and P. So let's define those. What's N in this case? 5, because we want to know that's going to take 5 drives. And what's P? 3%. Good. So we'll go ahead and use that formula, the probability that x is going to be 5 is going to equal 1 minus p. So what's that? 97 or 97% chance that they're going to be good for the first four. And so we're going to do 5 minus 1, right? So notice the first four, there's a 97% chance that those first four are going to be good. And then the last one, there's a 3% chance. So let's calculate that and see what we come up with. Okay, do I have confirmation? Yes. Okay. And then we're going to pause it right here while we pose the question for the last one. So the last part is going to say, find the first four entries in the table of the PDF for the random variable x. So we'll pause here, and we want to know, what about what would be the probability that happens in the first one, the second one, the third one, and the fourth one? We already know that the fifth one is 0.0266.